Welcome, students. Today we're going to be solving equations in quadratic form. I want to look back at a topic that we looked at earlier, factoring expressions in quadratic form. We're going to do an example that is similar to what we've seen before, and then we're going to look at it a little bit differently in the form of an equation. So what I want to do first is do an example of a problem that we've already seen before. Let's factor x to the fourth minus 3x squared minus 4. Now, this is a trinomial, but it's a little bit more complicated than a lot of the trinomials we've factored because we've got these higher exponents. So we need to make a z substitution so that we can rewrite this in the form something squared minus 3 times something minus 4. Now, what quantity can we square and end up with x to the fourth? The answer is x squared. If you take x squared and square it, that's x squared times x squared, you end up with x to the fourth. Also, if we put an x squared in here, it matches up. 3x squared is the same as 3 times x squared. So the substitution that we have to make here is we have to let z be equal to x squared. If we do that, then this expression becomes z squared minus 3z minus 4. And we can factor this. We use the unfoiling method. We need two numbers that have a product of -4 and a sum of -3. Those numbers are -4 and +1. And then we have our factorization, but remember, we have to rewrite this in terms of x because it started off in terms of z. And so here we're going to replace z with x squared. So that's going to be x squared minus 4 times x squared plus 1. And we can go even further here. X squared minus 4 is a difference of squares. So that can be broken down into x plus 2 times x minus 2, and then x squared plus 1. This is something that we have already seen before. We've already used these z substitutions to factor polynomials in quadratic form. But instead of factoring today, our goal is actually going to be solving. We're going to want to solve an equation that's in quadratic form. So we might have x to the fourth minus 3x minus 4 equals 0. And our goal isn't factoring, though we will end up factoring as we do this problem. The final goal here is going to be solving for x. Now here, we're still going to start by making the same substitution, because dealing with a fourth degree polynomial is much more complicated than a second degree. So to turn this into a quadratic, we're going to let x squared equals z. And when we do that, we end up with z squared minus 3z minus 4 equals 0. Now once we've done this, we can still factor that polynomial. It's still going to be z minus 4 times z plus 1 equals 0. But instead of going back to x right now, what we're going to do is we're going to solve for z first, and then we're going to go back to x. So at this point, if we want to solve for z, we have a product of two factors equals 0. So we know that one of those factors has to be 0. So we say z minus 4 equals 0, or z plus 1 equals 0. And when we solve for z in each of these, we get z equals 4 or z equals -1. But that's not going to be our final answer. We weren't asked to solve an equation with z's. We were asked to solve an equation with x's. So we need to figure out what x is going to be. And at this point, we can substitute back in. Instead of the z, we can write x squared. So we've got x squared equals 4 or x squared equals -1. And now at this point, we can use the square root property to take the square roots of both sides. In the first equation, the square root of x squared is x. And then on the right, we've got plus or minus. The square root of 4 is 2. And then or, again, the square root of x squared is x. And then we've got plus or minus. What's the square root of negative 1? That's the imaginary number I. So here we end up with x equals plus or minus 2, or x equals plus or minus I. This represents 4 solutions: 2, negative 2, I, and negative I. So if you are asked to enter this into a homework system as a comma-separated list, you would enter this. Now the reason we had 4 solutions is because this was a 4th degree polynomial. The degree of the polynomial in the equation gives you the maximum number of solutions that that polynomial equation can have. Now I want to look at one more example. And this example is going to be a little bit different from all of the examples that we've seen before. However, I think you are ready to tackle it. Let's solve x minus 7 times the square root of x plus 12 equals 0. This is really different from anything we've seen before because we have not been solving equations that have square roots of variables in them. Now, I'm going to walk you through this step by step and explain each of the steps. Let's tackle this. So this is very similar to a quadratic equation. We have 3 terms. One of those terms is a constant term. The other 2 terms have variables in them. This is just like the last one we did. We had a trinomial, we had a constant term, and then 2 terms with variables. And there's another similarity here. If you look at this x term, and you look at this square root of x term, x is the square of the square root of x. If you took the square root of x and squared it, you would get x. Just like here, when we take x squared and square it, we get x to the 4th. So what we're going to do here, we're going to need to put this in quadratic form. So we want to write this as something squared minus 7 times something plus 12 equals 0. Now what can we square to end up with x? Well, the answer is the square root of x. And if we put the square root of x in that parenthesis, it matches that term as well. So the substitution we're going to make here is we're going to let z be the square root of x. If you've ever got an equation in this form where you've got an x and then a square root of x, the substitution that's going to work is letting z be the square root of x. Now if we do that, this becomes z squared minus 7z plus 12 equals 0. And now we have a quadratic equation. And this one can be solved via factoring. We're looking for 2 numbers that have a product of 12 and a sum of negative 7. Those numbers end up being negative 3 and negative 4. Now we set each factor equal to 0. Z minus 3 equals 0, or z minus 4 equals 0. And when we solve, we get z equals 3, or z equals 4. I'm going to rewrite that up here where I have more room. Z equals 3, or z equals 4. Now, because the original equation had x's in it, we need to solve for x, not for z. And so we have to make our substitution again, but this time to go back from z to x. So we have the square root of x equals 3, or the square root of x equals 4. And now we need to solve these equations, and these are a little bit different from things that we've seen before. So we're going to have to do a new little trick here. Whenever you have the square root of x equals a number, whenever you have a variable inside a square root, the way that we can undo that to get it out of the square root The opposite of taking a square root is squaring. So what we're going to do is we're going to square both sides of these equations. And I'm going to do it for both of them. And this is a property of equality. This is a rule that we're allowed to do. We may square both sides of an equation. Now let's see what happens once we do that. The square root of x squared is just x, because taking the square root and then squaring, those are opposite operations. They undo each other. On the right-hand side, 3 squared is 9. And then when we do that to the other equation, the square root of x squared is x, and 4 squared is 16. So we end up with x equals 9 or x equals 16, and that is our final answer.